A thin-walled cylindrical pressure vessel has mean wall thickness of T and nominal radius of R. The Poisson's ratio of the wall material is 1/3. When it was subjected to some internal pressure, its nominal perimeter in the cylindrical portion increased by 0.1% and the corresponding wall thickness became T bar. The corresponding change in the wall thickness of the cylindrical portion, that is 100 into T bar minus T by T, is, so we will have to find out the change in wall thickness as a percentage, and we have to round off the solution to 3 decimal places. Let's look at the solution. We know the mean wall thickness of the cylindrical pressure vessel is given as T, which is R. We also know the Poisson's ratio of pressure vessel wall material, which is mu is equal to 1/3. Change in nominal perimeter is nothing but hoop strain, which is given as 0.1%. Wall thickness due to the nominal strain was also given as T bar. Now, we would like to find out the change in wall thickness of the cylindrical portion, which is delta T by T, which is nothing but T bar minus T by T. Since it is given as hoop strain is equal to 0.1%, hoop strain for a thin-walled cylindrical pressure vessel is PD by 4TE into 2 minus mu, where P is the internal pressure, D is the diameter of the pressure vessel, T is the wall thickness, and E is the modulus of elasticity. On the right hand side we have 0.1%, which is 0.1 by 100. So substituting the value of mu is equal to 1/3, we get the value of PD by 4TE as 0.1 by 100 by 2 minus 1/3. Now for a cylindrical pressure vessel, we have hoop stress, which is considered as sigma 1, and it is represented as PD by 2T, and we have longitudinal stress, which is taken as second principal stress, and it is represented as PD by 4T. From these two equations, it has to be understood that sigma 2 is equal to sigma 1 by 2. Now, the radial strain for the cylindrical pressure vessel is delta T by T, which is 1 by E into sigma 3 minus mu into sigma 1 plus sigma 2. Now, delta T by T is minus mu by E into 3 sigma 1 by 2. That implies delta T by T is equal to minus 3 mu into PD by 4TE. Since sigma 2 is equal to sigma 1 by 2 and sigma 3 will be equal to 0 for a thin-walled pressure vessel. Substituting the values, we have delta T by T as minus 0.06%. The accepted answer range for this question is minus 0.062 to minus 0.058.